The big title for this talk is Constructivism and Negentropy, and the subtopic is Cybernetics, Logical Necessity, and Constraints. And my name is Keith Allward, and I'm happy to have this session with you. There are two major problems for developmental sciences. One is, how are organisms capable of a reliable interaction with the world that leads to their subsistence? The second law of thermodynamics states that systems tend towards entropy, which is expressed as disorganization. Nature abounds with complexity, and organization expressed as negentropy. And how is that possible? These are two major problems for developmental sciences. The answer to both questions, I believe, is suggested by the way we solve newspaper puzzles. We solve newspaper puzzles by recognizing what is possible, impossible, and necessary in the various cells of the puzzles. And I call these conditions constraints. When multiple constraints have the same consequences, that is, fill the cells in the same way, the constraints form a mathematical group. And the world exists and is preserved because the constraints that make the world possible are embedded in group structures which underlies their conservation, the conservation of the elements of the world. I want to talk about the relationship between psychology and cybernetics and constructivism. So this is about Piaget and Norbert Wiener. The answer that I'm suggesting is consistent with Piaget's theory of increasingly coordinated interactions with the world, eventually organized as grouping structures created through free exploration, i.e. through constructivism. This answer that I'm suggesting is also consistent with Norbert Wiener's concept of positive and negative feedback loops, revealed by a constructivist observer whose own existence is possible only because of positive and negative feedback loops. For those interested in this, I would suggest that you might Google cybernetics and constructivism. The heart of Wiener's cybernetics is positive and negative feedback. Feedback loops concern the production or outcomes of systems, and examples of outcomes are energy, information, and problem solving. Outcomes can affect the process of production, and when an outcome increases production, it is considered to be positive feedback. When an outcome decreases production, it is considered to be negative feedback. Cybernetics in puzzles. If an outcome of trying to solve a puzzle is failure to recognize a critical constraint, the puzzle solving will slow down and possibly fail, that is, negative feedback. And if an outcome in trying to solve a puzzle is properly recognizing critical constraints, the puzzle solving will speed up and possibly complete itself, that is, positive feedback. Now to a couple of puzzles which will serve as examples. While I'm doing the puzzles, look for instances of impossibility, possibility, and necessity. And also look for instances where different constraints give the same meaning, i.e. give the same cell contents. This is the Ken puzzle, which occurs daily in the New York Times. It's basically a matrix puzzle in which each of these numbers has to occur in each row and in each column with no duplicates. And they give you two already in this cell, and the problem is to figure out what goes in all the other cells. The first thing that I see is that let me tell you what these numbers mean. This means that there are those numbers that go into these three cells have to add up to 6, the add sign, 6. These are 3 cells that have to add up to 8. These are 3 cells that add up to 8. And these are 4 cells that add up to 11, and these are 2 cells that add up to 5. The only numbers 3 numbers out of this set that can give you 6 are 1, 2, and 3. So therefore a 4 has to go here. There's another reason that a 4 has to go here, and I really want you to understand that these constraints that determine what's possible, impossible, and necessary, there are multiple constraints that lead to the same outcomes. 4 could be because it can't be one of these, 4 can't be here, but it could also be 4 because these three numbers add up to 6, and this number is 5, and 4, and 6 and 4 are 10, which is what these 4 numbers add up to. So these numbers are going to ultimately add up to 10, and since this is 6, this has to be 4. If this is 4, and these two numbers together have to be 5, then this must be a 1, by necessity. And if that's a 1, then these two numbers over here have to be 2 and 3, because they can't be a 1 or a 4. So I'm going to put down 2 and 3, and 3 and 2, because I don't really know where they go, but this is either a 2 or a 3, and this is either a 2 or a 3. If that's the case, these two numbers add up to 5, and altogether these 4 numbers add up to 11, then these two numbers have to add up to 6. And the only two numbers up here that will give you 6 are 2 and 4. But again, I don't know which cells they go into. So I'm going to say this could be a 2 or a 4, or this could be a 2 or a 4. These two numbers are going to be a 3 and a 4 because they can't be a 2 or a 1. So again, I'm going to put down a 3 and a 4, or a 4 and a 3, and those are the possibilities. There cannot be a 4 because if that was a 4, you'd have two 2's here, and that violates the rules of the puzzle. So therefore, this cannot be 4, and therefore, by necessity, it must be 3. And if this is 3, this can't be a 3 up here, so this by necessity is 4. These numbers here is either a 1 or a 2 or a 3, but it can't be a 2, and it can't be a 3. The reason it can't be a 2 is because if it was a 2, then these would be both 4, and that wouldn't work. So it has to be a 1. And this number up here is a 1, 2, or 3, but it can't be a 2 because there's already a 2. So it's either a 1 or a 3. But it can't be a 1 because we already have a 1. So therefore, it's a 3. And the only number left for this one is a 2. So now we have that column complete and this column complete. And over here we have two numbers that are missing. They can't be a 3 or a 2, so it must be a 1 or a 4. And these three numbers altogether add up to 8, and these two numbers are already 5, so therefore this number must be a 3. 3 plus 5 is 8. But I don't know which one is which here. But these three numbers add up to 8, and we already have 7, a 3 and a 4, so therefore this number has to be a 1, and therefore this number cannot be a 1, it has to be therefore a 4, and then that's a 1. If this is a 2 or a 4, but we already have a 4, it must therefore be a 2, and this is a 2 or a 3, but it can't be a 2 because we already have a 2, and this can't be a 2, and therefore it's going to be a 4, and this one cannot be a 3 because we already have a 3, so therefore it's a 2. So now the puzzle is complete, and one can see that there's no alternative place of content for each of these cells. The cells have been determined by the fact that there are multiple constraints. Then the constraints, when they're multiple like that, constitute something called a grouping, and because their constraints organized as a grouping, this puzzle is conserved. This puzzle is called a cryptoquip, and it's a cipher puzzle in which these letters have to be figured out which letters in the alphabet they actually are. Right now, it's all noise. You can't tell what it says. I count the number of letters that occur here. B occurs 9 times, which is a lot. H occurs 6 times. S occurs 6 times, and C occurs 9 times. Typically, if a letter occurs more than 6 or 7 times, it's a vowel, almost certainly. The interesting thing about this puzzle is that the constraints are not like logical constraints as in the Kin puzzle or arithmetic constraints, but the constraints are from the structure of language and the structures of redundancies in the culture. And interestingly enough, I do these almost every day. I never make a mistake, very seldom make a mistake, very seldom am I not able to solve them. But it's all based upon guesses about the English language and about culture. It's not about certainty, but in the end, the puzzle is solved with certainty. Notice here we have a single letter with an apostrophe S, Z. That has to be an I. The reason it's an I is because there's also a B down here by itself. So it's either an I or an A, and there is no A apostrophe something in the English language that I know about. So I am going to say that this is an I. And if that's an I, then there's a lot of other I's. Okay, there's another M over here, and that word is going to be either my or me. And it's a guess, but I'm going to say why. And the answer is my. I mean, the word is my. I don't think there are any other Y's in here. Yes, there's one over here. I noticed that there's an I here and an I here followed by 2 letters, and they're both the same letters, S and F, S and F. And I'm going to guess that that's ing, I-N-G, because that's, in my experience, when you have I in the same 2 letters in a number of words in the same corpus of language, it's often I-N-G. I made the guess that that was an N, and in which case there are other letters that become N's, and here's one, here's one down here, and this is looking like it's something. If maybe I'm going is a likely on and, so I'm going to say that this is an F, and we'll probably find another F in here, and this is a G, which we had already determined before from here. So now this is an O, and this is an O. If I'm going on, and makes a lot of sense. So now I've filled in all the letters that we've determined, and I've got some language here. If I'm going on and, it looks like African is likely, in which case that's a capital A. And this looks like it could be safari. I'm not going to fill it in yet, but I'm just going to read it. If I'm going on an African safari, I think this is going to be always bring something, I don't know what. And then over here is a word that's very familiar to me, but I didn't pick up on it, which is a 4-letter word in English that starts with this and ends with the same letter and has an A in it. It's quite likely that this is that, in which case all the A's are T's and all the E's are H's. And so now I'm going to finish that off a little. So I've gone ahead and filled in all of the letters that we have based upon words that we've already deciphered. And I've indicated up here which consonants we've used and which vowels we've used. We have not yet used B or D or J or K, and we haven't used E in U, etc. But we have something that's approaching a pretty clear concept here, which is it has something to do with African, has something to do with safari, has something to do with lions, and the rest of it's not too clear yet, but we can figure it out pretty easily. It's if I'm going on an African safari, I always, so that gives us the W's now. I'm not going to write it in. Bring, that's our B, which is missing. Bring my, and this is, I'm almost positive is going to be sketchbook, because this is K for O for sketch, and this is K for book. And this is going to be, we don't have E's yet, but we have TH from our that, so this is almost certainly an E, in which case these are E, and almost certainly this is W, where bring my sketchbook, period, this is a capital, that's where I think this is going to be draw the line. So here we have, I haven't filled it in yet, but I don't think I need to. Here you have clearly what the answer is to this cryptocrypt. We've deciphered it. I think deciphered it with certainty, even though all along we had to make guesses, but they were guesses based upon our understanding of spelling, the English language, and redundancies in culture, which is a redundancy here is, for example, African safari lion. I couldn't resist filling in the rest of the letters. Up here I've indicated all of the consonants that have been used, which is quite a few of them. It's unusual to have one that doesn't use all the vowels, but this one did not use a U. And it is what I thought it was. If I'm going on a safari, African safari, I always bring my sketchbook. That's where I draw the lion. Okay, what conclusions can we make from this example with puzzles? The bigger point that I'm making is that the consolidation of constraints in grouping structures underlies all reliable interactions with the world, that is, all conservations. The same mechanisms underlie coherence and functionality wherever negentropy or order and complexity has triumphed. Werner proposed that nature, machines, and reason itself were possible because of feedback loops. I would add that nature exists where feedback loops exist within a closed ecology where some states are impossible, some possible, and some necessary. These are the constraints of nature, machines, and reason, and their coalescence in grouping structures is what brings forth the successes of each. The mechanisms of understanding are the same as those that assure the existence of the things being understood. This conclusion is compatible with Piaget and Norbert Weiner's theories.